download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about bond energies. Now, whenever a chemical bond is broken, energy must be supplied to break that bond. Now, it's important to note that different bonds require different amounts of energy to break. So it takes different energy to break up a hydrogen bond, for example, than it does between a bond between two oxygens. And therefore, that must mean that when a chemical bond is formed, energy is released. And I know that's a difficult concept to get your head around, but when a chemical bond is formed, energy is released. And again, different bonds release different amounts of energy. Now, in a reaction, the bonds in the reactants are broken and then bonds in the product are formed. The first process therefore requires energy and the second process will release it. So let me go through an easy example to help get your head around this. So hydrogen plus oxygen to make water. Okay, so hydrogen, H2, plus oxygen, O2, to make H2O. Then of course we need to balance that equation out. So in order to do that we need two lots of them and therefore two lots of them to balance the equation out. Okay, so if we draw these out, that would mean that we've got two hydrogens here, two lots of H2 and one lot of oxygen and oxygen here. Okay, now the point here is that energy must be supplied to break these bonds, these initial bonds in the reactants. Okay, so energy must be supplied to break the bonds between the hydrogens and the oxygens. And again, a different amount of energy will be required to break these bonds with the hydrogen and these bonds with the oxygen. Okay, and then what we're going to form is two lots of H2O. Now, we need energy is released when these bonds are formed. Okay, so in our reactants, energy must be supplied, and then this energy is released when our new bonds is formed between to make the H2O. Okay, so the first process, i.e. this process here, requires energy, and the second process to then form the new bonds will release energy. Now, if more energy is released than is required, the reaction will be exothermic. If more energy is required than released, the reaction will be endothermic. And we can therefore work out if a chemical reaction will be endothermic or exothermic by looking at the energy required to break the bonds in the reactants and the energy required to form new bonds. And these are called bond energies. What you are therefore given is a table that looks something like this, which shows all the bonds and the amount of energy it takes to break or form that bond. So let's go through a worked example. A substance has one C and to Cl bond with a 1C to nitrogen bond. So one carbon to chlorine bond and one carbon to nitrogen bond. How much energy is required to break these bonds? Well, what we have to do, we have to look in our table and find each of these bonds. So we'll do carbon to chlorine first, which is here. And the energy required to break that bond is 346. So we write that down there, 346 kilojoules per mole. And then the second bond is the carbon to nitrogen bond. So we need to look for that on the table. And here it is. And then the amount of energy to break that bond is there. So C to N is 286 kilojoules per mole. Now, to find the total amount of energy that it is required to break both of these bonds, all we have to do is add them up. So 346, add 286, and you get 632. So 346 add 286, which comes from there, gives you 632 kilojoules per mole. So that is the total amount of energy required to break these bonds. So what I now want you to try and do is answer these 4 questions here using the table provided. And we'll go through the answers after, so pause the video now. Okay, so question 1. A substance has one carbon-hydrogen bond. How much energy is required to break it? We have to find it, and that's here, and it's 413. So 413 kilojoules per mole to break that bond. Question 2. A substance has 4 carbon-hydrogen bonds. How much energy is required to break these bonds? Okay, so we need to find our carbon and hydrogen bond. Again, it's 413. That's just here. And there's 4 of those, so we need to times it by 4. 413 times 4 equals 1,652 kilojoules per mole for that one. Question 3. A substance has 3 CH bonds and 1 CCl bond. How much energy is required? So C to CH, we've just worked out as 413, and it has 3 of those, so we do 413 times 3, which should get you 1,239. And it's also got 1 C to Cl bond, which when we look here, it's here, so 346. Then we need to add that number to that number, so 1,239 add 346, and you should have got 1,585 kilojoules per mole for your answer for that one. And then finally, a substance has 1 CH bond and 3 CCl bonds. How much energy is released when it is formed? So CH is 413 and C to Cl is 346, but there's 3 of those, so we need to times that by 3. 346 times 3 gives you 1,038. Add that to that, so 1,038 add 413, and you get 1,451 kilojoules per mole as your answer for that one. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Now we also need to be able to work out the overall energy change in a reaction. So I'm going to take you through a worked example here. So we've got hydrogen plus chlorine makes 2 lots of hydrogen chloride. Now we need to work out the overall energy change in this reaction. So we need to work out the energy that was needed to break these bonds here and the energy that was released to form these new bonds here, and then calculate the difference. So first thing you've got to do is write out the balanced equation. So number 1, write out the balanced equation. Now in our question, we've been given a balanced equation, and therefore we do not have to balance it again. So we're going to write out our balanced equation, which is here. Now in step 2, it's really helpful if you draw out all the molecules in the reactants and in the products so you can see what you're dealing with. So on one side, you're going to write reactants, and on another side, you're going to write products. And then you're going to draw out your reactants and your products. So H2 is H, so 2 H's, that's this one here. And your chlorine is Cl and Cl. So that's me drawing out my 2 reactants. And then I'm going to draw out my products. I've got 2 lots of HCl. So I've got H bonded with Cl. And I've got 2 lots of them. Okay, so there are my drawings. And then what you want to do, you want to label them with the bond in each of the molecules. Okay, so here we've got a H and a H. Here we've got Cl, Cl. Here we've got H, Cl. And here we've got HCl. Okay, so step 1, write out your balanced equation. Step 2, draw your reactants and your products. And then step 3, label them with the bonds. Now for step number 4, you need to work out how much energy is required to break the initial bonds of the reactants. So we've done this. You just did this really in the previous slides. So we need to calculate how much required to break our first bond, H and H. So on the table here we find it, H plus H is 436. So it takes 436 kilojoules per mole to break that bond. And then Cl is here. So it takes 243 kilojoules per mole to break that one. Okay, and to find the total, all you need to do is add them together. So 436 add 243, and the answer is 679 kilojoules per mole is required energy to break those two bonds. And then we go over to our products and work out how much energy is released when we form the new bonds. So we've got H and Cl, so that's here, so that's 432. And we've got HCl again, so that's also 432. So all we have to do is add those together. 432 add 432 is 864 kilojoules per mole. So what that means is it requires 679 kilojoules per mole energy to break the initial bonds, and then when the new bonds form, they release 864 kilojoules per mole of energy. Now to work out the difference, what we have to do is we have to do the energy required to break the bonds of the reactants minus energy released when we form the new bonds. So that's energy of the reactants, take away energy of the products. So 679 minus 864. So all you have to do is put that into a calculator, 679 minus 864, and you get minus 185 kilojoules per mole. Now what this minus number represents is that the reaction was therefore exothermic. Okay, more energy was released when forming the new bonds than needed to be supplied to break the initial bonds, and therefore the reaction was exothermic. If it wasn't a negative number and if it was a positive number, then it would be an endothermic reaction. So do remember that. Negative number equals exothermic, positive number equals endothermic. Okay, so just to go through what we did, number 1, balance the equation. Number 2, draw out your bonds. Number 3, label your bonds. Number 4, calculate the energy required to break the initial bonds. Step 5, calculate the energy released when we're forming the new bonds. And then you want to work out the overall change. So you do energy required to break the bonds minus the energy released, and then that gives you your final number. And if it's negative, it's exothermic, and it's positive, it's endothermic. So now I'd like you to do is have a go at this question here, and then we'll go through the answer together. So pause the video now. Okay, so let's go through. So step 1, we need to balance the equation, okay, and the equation has already been balanced here, so we're just going to write it out, so we do not need to worry about balancing that equation. Then in step 2, remember, we've got to draw each of our bonds, okay, so we're going to put the reactants on the left and the products on the right to make it easy to follow. So we've got CH4, okay, so we've got 1 carbon bonded to 4 hydrogens. So 1 carbon bonded to 4 hydrogens. Plus 2 lots of oxygen. So 2 lots of oxygen. So that's oxygen. That's oxygen bonded with oxygen. And oxygen bonded with oxygen. Okay, so there are our reactants drawn, and now we need to draw our products. So we've got carbon dioxide, which is carbon bonding to 2 oxygens, so that's that there. And we've got 2 lots of H2O, so that's 1 oxygen bonded to 2 lots of hydrogen. So that's that drawing there, but we've got 2 of those, so there's that. Okay, so now we've drawn each of our reactants and products. We now need to label each of the bonds. So here we have a CH, here we have a CH, and here we have a CH, and here we have a CH. That's 4 CH bonds. Here we have OO, and here we have OO. And then in this one here we have C to O and C to O. And in our 2 hydrogen HOs we've got HO, HO, and we've got HO, HO. So lots of bonds to work out here. So now we need to calculate the total amount of energy required to break the initial bonds. So we've got 4 lots of CH. So if we go on our table, CH is 413, and we got 4 lots of those, so all we have to do is 413 times by 4, so that gives us 1,652. And then we've got 2 lots of OO bonds, and O equals O is 498, and as I say, we've got 2 lots of those, so we need to do 498 times 2, so 498 times 2, and that gives you 996. To work out the total, we add those together, so 996 add 1652, so it takes 2,648 kilojoules per mole of energy to break the initial bonds. Now we need to work out the amount of energy that is released when the new bonds are formed. So here we've got 2 lots of C equals O bonds, which is 799, and we've got 2 of them, so 799 times 2, which gives you 1,598. And then we've got 4 lots, if we can see 1, 2, 3, 4 of these HOs. So we've got HO, which is 464. We've got 4 lots of them, so we need to times it by 4. 464 times 4, which gives 1,856. And I hope you can see now why it's really important that we draw these bonds out, because it really helps us to see them. So to work out the total amount of energy released, we add these 2 numbers together. So 1856 add 1598, and that gives you a total of 3,454. So now to find out the overall change, we've got to do the amount of energy to break the bonds, take away the amount of energy supplied to form the new bonds. So it would be 2,648, which comes from here, take away 3,454, which comes from there, and we put that in the calculator. 2648 take away 3454, and that gives you a total of minus 806 kilojoules per mole. And you'll remember from before that a minus number means that it's an exothermic reaction. Now we have lots of these practice questions in our quiz and in our exam questions, so please do make sure you keep practicing this, okay? If there's anything you didn't understand, then please get into contact with one of our tutors who will be happy to help.